So just how bad is 8 gigabytes of VRAM in 2023? If you listen to some people, there's only a few unoptimized games that are just garbage, ignore those. 8 gigabytes of VRAM is fine. If you listen to other people, 8 gigabytes of VRAM is complete obsolete garbage, throw it in the trash and get something else. Is the truth somewhere in between? Well, I think what we're gonna, where some of the problem comes down to is, first of all, people may be only looking at maximum settings. So in this video, we're gonna definitely look at different settings. Also, some people look at the stats counters in their games and might not fully understand how to read them. We'll talk about that a little bit. But also, I think some people focus on older games and other people focus on newer games. So in this video, we're gonna focus on games that have released throughout 2023, starting with the newest, Ratchet and Clank, which just came out. And then we'll go down all the way back through games releasing throughout the year back through January. We'll test them at multiple graphic settings at 1080p, 1440p, and 4K resolution, and measure exactly how bad the 8 gigabytes is limiting the performance. Now, what should you be looking for here? Well, on the left-hand side of the screen, we're seeing the 4060 Ti 8 gigabyte. On the right-hand side of the screen, we're seeing the 4060 Ti 16 gigabyte. NVIDIA, well, has maybe not released an exciting value card with the 16 gigabyte, and this isn't really a review of that card, although you could certainly use it as that. This is really just that we've got an unusual opportunity now to look at identical GPUs, one with 8 gigabytes and one with 16 gigabytes, to measure exactly how much is the VRAM impacting the performance. Also, let's talk about the stats counters up here. They might be a little bit hard to see, but in the green memory line is the first number it's showing you here is the allocated VRAM in the game. And a lot of people look at that and think that's how much the game actually needs. But the next number here is the reported per process usage. And that's, I think, a better number for how much the game is really needing. But even if it's going over 8, how much is actually affecting your performance? And that's what's been so hard to answer without having an 8 gigabyte and 16 gigabyte version of the same graphics card, which we now have. So thanks, NVIDIA, for the 4060 Ti, I guess. Here you can see why some people feel like with their 8 gigabyte graphics card, they're fine, because here it's reporting, you know, a little over 7 gigabytes of allocation and under 7 gigabytes of actual usage. But check this out. Right here, this is system RAM allocation and per process usage. And you see the same numbers here. Do you notice the per process usage is a lot lower on the 16 gigabyte card and a lot higher on the 8 gigabyte card? So what does that mean? It means that the 8 gigabyte card has spilled over from VRAM into system RAM. And what does that do? Do you notice the more spikes on the frame time graph here? Also, just lower overall performance. And I've summarized the overall performance in the little chart at the bottom left here, where you can look at the average FPS at the end of the benchmark segment that I'm showing you, as well as the differences in the 1% lows, the lowest 1% of frames. And the 1% lows also can show up as spikes in the frame time graph, where smoother is better. So that's what we're looking at here. The specific GPUs, again, are the 4060 Ti 8 gigabyte is the NVIDIA Founders Edition. There is no Founders Edition of the 16 gigabyte card. So my 16 gigabyte card is the Gaming OC version from Gigabyte. They're both at their out-of-the-box settings, but as we'll see later in the video, when we're not VRAM spillover, the difference in performance is either nothing or within 1 or 2%. Here we can see a 34% performance improvement by going from 8 gigabytes to 16 gigabytes. We see reported usage over 8 gigabytes, and we see lower system RAM, smoother frame time graph, and the 1% lows are 37% better as well. Now, if you're already feeling like you need to just give up on your 8 gigabyte GPU and sell it, well, let me tell you about today's sponsor, Jawa.gg, where you can get your best price for your GPU. Now, a lot of people hang on to their old graphics cards or aren't really sure what to do with them. Well, you should definitely sell it to fund your upgrade when you're upgrading your GPU. And Jawa gives you two very interesting options. One of the options is to list it for sale yourself, where you get to pick your own price, but you do then manage the listing. you know, you're dealing with a third-party buyer, and then you have to ship it out, and you get paid 2 days after the buyer receives the GPU. It's all good, but I do know a lot of people who just want to avoid the hassle, and that's where Jawa offers something very interesting. They offer a hassle-free and no need to wait on a buyer or deal with a third party at all option where you can sell directly to Jawa. You just tell them your GPU model and condition, they offer you a price immediately. You ship your GPU to Jawa, they receive it, inspect it, and pay you in 1 business day. You just click get an offer, and this link will be available in my video description and pinned comment. Anyway, let's get back into the overall benchmark results here. So we see at 1080p, very high settings with very high ray tracing enabled. We are seeing a noticeable performance bump here in this game, but what if we go up to 1440p resolution? At 1440p resolution, we are seeing a 43% average improvement to the frame rates. It's 43 frames versus 30 frames. That is a very big difference. And the 1% lows are also a 47% bump, 25 versus 17. So a very noticeable difference in playability at these settings. Now, let's jump a little bit farther. We'll go to 4K very high ray tracing settings. And now we're seeing an 85% performance improvement by going up to the 16GB card. Now, you might be like, but the overall frames are only 23 versus 13. They're both unplayable. Remember, that would be relevant if I was reviewing the 4060 Ti models, but I'm just looking at what is the impact of 8GB versus 16GB. So regardless that the frame rate numbers were low there, we can tell that there's a massive difference in performance between 8 and 16. However, let's go down to turning off ray tracing. So now we're at 1080p very high settings, no ray tracing enabled, and we're seeing 90 FPS versus 67. That is a 34% improvement. We're going from, yeah, we can get about 60, but the 1% lows are pretty bad, to going a high FPS, you know, or 90 FPS range by the end of this run. It's a very noticeable improvement jumping up to the 16GB card. If we jump to 1440p resolution, we're seeing 36% better performance in the averages and 47% better performance in the 1% lows. So you're just massively hurting your performance. I mean, it goes from under 60 FPS, we're down in the low 50s, up in the 70 FPS range by increasing the VRAM capacity. And of course, going to 4K resolution further accentuates this. 42% improvement to the averages, and 2.31 times the performance in the 1% lows. The 1% lows here are 30 versus 13. That is a massive difference in playability. And we're going from, sure, you're not getting 60 FPS, but maybe on a controller you're fine with 4K very high here, down to, you know, frequently below 30 FPS. It's a major difference. But okay, what if you're just like, yeah, but I'll just click down to the high settings? Well, believe it or not, in this exact same scene, I'm actually seeing at 1080p, down to 1080p, high settings, 52% better performance, 103 versus 68, and 56% better in the 1% lows by going to the 16GB card. And at 1440p resolution, I'm seeing 81 FPS versus 59, which is a 37% improvement on the averages and a 21% improvement in the 1% lows. I'm a little confused why the 1080p results showed a bigger gap than the 1440p results, but it's the result I got. So anyway, let's move along here. 4K high, we're seeing 50 FPS versus 36, which is a 39% bump. But anyway, let's move on to some other games, although it is a 50% bump in the 1% lows. Now, how about Unreal Engine 5? We have some of the first released games in Unreal Engine 5. This is Remnant 2. This game came out in July 2023, so this just came out a couple weeks ago. 1080p Ultra settings, I am not, by the way, this game does not have ray tracing in it, so we're just looking at 1080p Ultra, and then we'll also look at High, and we'll look at all the resolutions. This game is extremely demanding. It uses nanite. There's a lot of geometric detail, but we're only seeing a 5% improvement by going up to the 16GB card, and we're not seeing a lot of signs of actually spilling over VRAM, so I'm actually surprised we're seeing any difference at all. Maybe it's just variation between the benchmark runs. This isn't a built-in benchmark. I'm just trying to do exactly the same thing each time. Moving up to 1440p though, I see a 4% improvement, but that is like 1 FPS difference. It's just that shows up as 4% when you're at 29 versus 28. So again, it's probably just run-to-run variance. But we could jump up to 4K resolution where I'm seeing a 7% increase, but again, it's a 1 FPS difference. It's 15 versus 14. The 1% lows are 13 versus 11. So not crazy differences in this game at the ultra settings. If we go down to high settings, I'm now seeing a 2% improvement for the 16 gigabyte card at 1080p, no improvement at 1440p, and no improvement at 4K. So it seems like at high settings, 8 gigabytes is just fine in this game, and also it seemed like at ultra settings, it didn't make much of a difference either. Now, there's not a lot of Unreal Engine 5 games out there yet, but there will be a ton coming in the future, so this will be something that'll be worth keeping our eye on, but we'll just kind of have to see how it goes. One thing to note is that this game does not use the lumen lighting system from Unreal Engine, it just uses the nanite feature. So again, not sure how representative that will be. Now, Star Wars Jedi Survivor uses Unreal Engine 4. This came out in April of 2023. We're looking at the maxed out settings first. This is 1080p Epic settings with ray tracing turned on. And I'm only seeing a 3% improvement for the 16 gigabyte card and a 7% improvement in the 1% lows. I was actually surprised because this is one of the games that frequently reports at least allocating over 8 gigabytes. But so I was maybe expecting to see a larger gap here in actual performance, but that just wasn't the case. What if we move up to 1440p resolution? Again, we're reporting more than 8 gigabytes of usage on the card that has it, but we're only seeing a 2% difference in the average frame rates and a 5% in the 1% lows. At 4K resolution, though, it seems more meaningful, where we're seeing a let me jump back there a second, a 13% difference in the averages and a 57% improvement in the 1% lows. So it seems like it's at 4K resolution where we're actually seeing a large difference. And you can see the frame time graph on this one's extremely spiky, and here we're doing okay. Now, it's possible that at the lower resolutions, maybe textures weren't loading in properly and I just couldn't see it in my footage. But what if we drop down to high settings? So if we drop down to high settings, 1080p, there's basically no difference in the overall performance in averages or 1% lows. A difference of 1 FPS will just be minor differences between benchmark runs. At 1440p resolution, again, I would call this a tie. I think 2% differences, which are just 1 frames per second, are more likely to be just differences between benchmark runs or GPU cooler models, you know, that kind of thing, slightly different boost clocks. And at 4K resolution at high settings, again, there is actually no difference between the performance. So it's looking like, at least in Star Wars Jedi Survivor, if you go down to the high preset, 8 gigabytes of VRAM is fine, even at least in that scene, going up to 4K resolution. Now, The Last of Us Part 1, which came out in March 2023, is one of the games that really kicked off a lot of the VRAM panic. It wasn't the first game to have this problem, but it was one of the ones that really seemed to bring it to the forefront of a lot of the people's attention. Well, here, even at 1080p resolution at the ultra settings, you see a 19% performance improvement on the average going to the 16 gigabyte card and a 22% improvement in the 1% lows. So it makes a very meaningful difference even at 1080p resolution here. At 1440p resolution, it makes a 15% difference in the averages and a 17% difference in the 1% lows. And while this isn't supposed to be a review of these particular cards, it is showing that the 4060 Ti is capable of 60 FPS 1440p Ultra if it has enough VRAM, but the normal model doesn't have enough VRAM, so that is unfortunate. Now, at 4K resolution, the 8 gigabyte card just completely breaks, making it, the 16 gigabyte card 6 times faster and almost 10 times faster in the 1% lows. But what if we go down to high settings? Well, at high settings at 1080p, the cards are basically tied. I see a 2 FPS, 2% difference in the 1% lows, but they're both showing nice smooth frame time graphs. We don't really have an issue at high settings at 1080p in this game. At 1440p resolution, we're seeing some small differences, 4% in the averages, 7% in the 1% lows. And then at 4K resolution, we're definitely wanting more than 8 gigabytes. And here we're seeing a 12% lead in the averages and a 13% difference in the 1% lows for the advantage to the 16 gigabyte card. So it looks like the high settings are mostly good at 8 gigabytes, unless you're pushing into 4K. It seemed like 1440p had some limitation on the 8 gigabyte card. Let's jump into the next game. So this is Resident Evil 4 Remake, which came out in March of 2023 as well. 1080p max preset, which includes ray tracing, we see an 11% advantage for the 16GB card in the averages, but I want to point this out, a 77% advantage in the 1% lows. Let's actually go back and watch this footage again a little bit, and I want you to look at the frame time graph. Do you see those gigantic spikes? Now keep your eye on this frame time graph, a couple more gigantic spikes. So one way that a VRAM limitation presents itself in some games is spikes, stutters. They show up as spikes in the frame time graph, but they would be noticeable stutters in actual gameplay, and that's what we're seeing here. However, when the game launched, 8GB cards would actually just crash when trying to use this preset, and it's actually been only through patches to improve performance that it even runs on an 8GB card at these settings. At 1440p max, we're once again seeing the spikes in the frame time graph on the 8GB card and a perfectly smooth frame time graph on the 16GB card. So while it's only a 9% improvement to the averages, it's over doubling the performance in the 1% lows, 31 versus 66. So the averages don't really show the whole story here. You have a stuttery mess at 8GB and a buttery smooth experience on 16GB. And moving up to 4K, again, massive spikes on the frame time graph. We're now seeing a 24% difference in the averages and over doubling the performance in the 1% lows. So this one definitely wants more than 8GB at the maximum preset. However, the next step down in the graphics presets is prioritize graphics. And at these settings, at 1080p, the performance is virtually identical. Any differences here seem to just be margin of error on the benchmark run. At 1440p, performance is virtually identical at this preset, and even at 4K resolution, it's virtually identical at this preset. So basically, it's important in this game just to, if you have an 8GB card, go down to prioritize graphics, and away you go. Should be pretty much fine. Now, Returnal came out in February of 2023. This is its Epic preset, and at this Epic preset, we don't really see any meaningful differences between the 8GB and 16GB card, and it's not reporting more than 8GB of usage. Moving up to 1440p, once again, it seems like just margin of error between the two cards. And at 4K resolution, we're seeing a 5% improvement, which is only 2 FPS difference on the 16GB card. So whether you want to call that margin of error or maybe a little bit of an advantage here, it is allocating a bit over 8GB here. So that could be a 5% gain from having the 16GB. If we move down to high settings at 1080p, we're seeing a few percent difference, especially in the 1% lows here, but I'm almost wondering if it's just hitting such a high frame rate that maybe we're seeing a few little stutters here and there from like a CPU limitation entering the equation, something like that. I don't know. I wouldn't really chalk that up as a meaningful difference on those that we would want to read too much into. At 1440p high settings, again, some small advantages there, but it's a couple FPS, whether that's differences between the cooler models on the cards, boost clocks, that kind of thing, or an actual difference, I don't know. And then at 4K high, it's exactly tied, so no differences at all there. Now, in January of 2023, we had Forspoken, and at its maximum preset, which is called Ultra High, although I did switch it to not use upscaling. We'll talk about upscaling in a minute here. We're seeing a 33% advantage, 72 FPS versus 54 on the 16GB card, and that's at 1080p resolution, and this preset does use some ray tracing. If we jump up to 1440p at the Ultra High preset, we're actually seeing a 44% advantage for the 16GB card. I should also note that some of the textures don't always load in properly on the 8GB cards either in this game, and that is something that can happen in the other games as well. I've seen other YouTube videos where people have found more of the visual differences between the 8GB card and 16GB card in this video. Here I'm looking mostly at the performance differences. At 4K resolution, it's a massive 56% advantage to the 16GB card over the 8GB card. In this benchmark run, I'm not talking about the 1% lows because it goes through these load screens, which kind of throw off the 1% low results since the game kind of stutters a bit during those. Now, if we go down to the high preset, which does not use ray tracing and is significantly more performant, we are still seeing an advantage even at 1080p resolution for the 16 gigabyte card, although it's only an 8% advantage. It is still an advantage. And again, I'm not going through here to check to see if texture's loading properly, but that could also be another advantage. We're at 1440p, even at the high preset, we're seeing an 18% advantage on the 16 gigabyte GPU. And at 4K resolution, at high preset, it's a 25% advantage for the 16 gigabyte GPU. Now, the next thing I want to do, so far everything we've looked at has been games from 2023. And that's about to stop here with Cyberpunk, so I want to talk about what I'm actually doing here with Cyberpunk. In addition to this being a useful ray tracing benchmark, I actually want to talk about what about upscaling, okay? Because so far I've been running everything at native resolution. Using technologies like DLSS, FSR, or XeSS, and by DLSS I mean DLSS 2, not DLSS frame generation, DLSS upscaling, you can rein in VRAM. And I wanted to demonstrate that here in Cyberpunk and then talk about how frame generation actually increases VRAM usage, which has the opposite effect. So that's what I wanted to demonstrate here. So what I'm showing you here is at 1440p Ray Tracing Ultra preset, we can see that we do spill over 8 gigabytes of VRAM. We can see system RAM usage go up, and we see a 12% advantage and 15% in the 1% lows for the 16 gigabyte card. So we've found a situation where we are VRAM constrained on the 8 gigabyte card. However, if we go ahead and turn on DLSS quality without frame generation, you can see that the VRAM consumption goes down. There's maybe still a little bit of spillover, and now we have like a 4% advantage, which is a 2 FPS difference on the 16 gigabyte card, although the 1% lows are showing a larger advantage at 14%. But you can see that upscaling does reduce VRAM usage, and that's my main point here, is that, again, if you have a card with 8 gigabytes of VRAM, or whatever it is, but you're spilling over your VRAM, using technologies like DLSS, XeSS, and FSR does help reduce VRAM usage, but this brings me to an important distinction, not if you enable frame generation. So now I've enabled frame generation, and I want you to notice that we're using more VRAM with frame generation enabled and DLSS quality than we were when we were using when we were not using it. By the way, I think I've typed in the wrong percentage difference here in the 1% lows. This is 68 FPS versus 42 FPS. Sorry, I'm actually going to 68 divided by 42. That should be a 62%. Sorry, that should be a 62% advantage in the 1% lows here, which is what I was trying to demonstrate. So apologies for the, I'll just cover this up with my face. It's a 62% advantage in the 1% lows. Look at the 1% lows up here. If I go backwards a little bit, I want you to look at the frame time graph again. Like right here, looking at this frame time graph, do you see this one is very, very stuttery and this one is not? So I did want to bring up the point that frame generation does increase VRAM usage. So if you're on an 8 gigabyte card with frame generation and you're already right at that borderline, it can actually hurt your 1% lows. And again, sorry, I typed in the wrong number here. I'm not going to re-edit the whole video and all that. Okay, this has been a ton of information. Let's boil it all down here. A lot of people have been asking me to do more like summaries at the end of my videos. Look, honestly, I hate boiling everything down to an average because I think it kind of misses the point, but let's break this out here. So in the games I tested that had ray tracing, at 1080p, 1440p, and 4K, we can see the performance differences. I don't like this as an average, though. I think you can especially see why at the 4K result, because while I didn't show it to you, in Cyberpunk, at 4K RT Ultra, the 8 gigabyte card basically just breaks. It goes down to something like 4 frames per second, whereas the 16 gigabyte card is at like 13 frames per second, which is, more than tripling its performance. But then when you average those results, you see that you get 100% improvement, where in reality, most games are a much smaller improvement than that, but some of them just break. So I think a better way of reading this data is every single game, although maybe Jedi Survivor didn't matter much at 1080p and 1440p, but basically every game tested here, even at 1080p resolution, goes over 8 gigabytes of VRAM when using ray tracing at native resolution. And I think that's an important stat to look at here. And some of them, it's very significant with a more than 30% jump, even at 1080p resolution. In other words, by having 8 gigabytes, you're 30% slower than you could have been if you had a larger VRAM capacity. At 1440p resolution, we see a similar story, where every game except for maybe Jedi Survivor just being variants, shows improvement with going beyond 8 gigabytes of VRAM, and some of them, especially Forspoken and Ratchet and Clank, which, by the way, are PlayStation 5 games that have been ported to PC, and I think we'll see more and more of those as time goes on. Anyway, we're seeing some big jumps there, and at 4K resolution, sometimes the game just breaks at 8 gigabytes of VRAM. Or it gives you very, very large performance bumps. And that's how I think we should read that data and not get too hung up on the average percent improvement, too much there. Now, what about playing games at ultra settings and at high settings, okay? So let's take a look at that. So if you want to play games at the ultra preset, now I'm using ultra preset here. Not every game calls it ultra preset. So what I mean by this is the maximum preset the game had that did not have ray tracing built into it, okay? So the maximum rasterized preset is, I guess, what I mean by ultra here. At 1080p resolution, you can see that most games are still okay at 8 gigabytes, but the other way of reading this is at least 2 of the 5 games tested here that were 2023 major releases actually benefit significantly even at 1080p resolution by having more than 8 gigabytes of VRAM, and that's without ray tracing enabled. At 1440p resolution, it's still kind of those 2 games, but it's a much larger, well, actually, maybe not much larger. But anyway, those 2 still benefit. And then at 4K resolution, you can see that sometimes games just basically break on 8 gigabytes, or you get a larger percentage bump, and it does seem like Remnant 2, maybe that's helping out a bit more, and Returnal maybe helping us out a little bit there as well. And then if we go down to high settings, you can see that really the only games here that mattered much at the high setting were Ratchet and Clank and Forspoken. The other ones seem to be pretty much okay until you hit 4K resolution with The Last of Us Part 1. So I do think it's interesting, though, that the newest game on my list, which is Ratchet and Clank that just came out, is one of the games showing the largest bumps here. And again, that's even at high settings, not even, the ultra settings, and it even goes up to ray tracing enabled, where you see even bigger bumps, right? So how are we going to summarize all of this? I think I would basically say that people saying that 8 gigabyte GPUs are obsolete, I don't think are correct. I think they just might be, what does obsolete mean? Obsolete means literally like you're not going to be able to use it. It can't run modern games. And we can see here that most of these games at high settings run fine on 8 gigabytes and don't see much benefit by going past 8 gigabytes. But there definitely are games that do, and the most recent game on my list definitely does. Another thing I'll mention is that some of these other games ran worse at launch and have been patched since then to better operate at 8 gigabytes, and I'm actually curious if that will happen with Ratchet and Clank, and maybe over time it'll get patched to work better on the 8 gigabyte cards at the lower settings. And it can run okay on the 8 gigabyte cards, as you do see a big benefit by going up to 1440p. And again, this was a PlayStation 5 exclusive design game. So was Forspoken, so was The Last of Us. And it seems like a lot of those games that were designed with the PS5 system in mind certainly want more than that. And if you go up to the ultra settings, again, you can see that a lot of games are okay on 8 gigabytes, but some of them definitely aren't, and can see major performance improvements. And then it's with ray tracing enabled that we really see that ray tracing definitely kicks up VRAM usage, and you really get hammered by having the lower VRAM capacities. The other thing that I'll say is that, well, I think it's a little extreme to say, to say that 8 GB cards are obsolete. Obsolete's the wrong word. I think it's absolutely correct to say that you should expect or want more than 8 GB on a card you're buying in 2023, right? Because if you look at this, like a brand new major release like Ratchet and Clank, you can just see that there's a massive difference between having 8 GB and not. This is not the only game that's showing this, and I think that as time goes on, this will become more of the norm as the cross-gen games start to fade away, and on the console side, they might be targeting more of a 12 GB VRAM buffer or even more. A lot of times PC settings can go beyond that. But again, it is true that you can lower graphics settings, you can reduce the VRAM usage, you can upscale, but here's where this wasn't a 4060 Ti review, but I'm gonna say a little bit about the 4060 Ti anyway, which is you can absolutely see that a card like the 4060 Ti should have had more than 8 GB of VRAM. If you wanna look at it like that, this is, I'm not saying this is a ringing endorsement for the 16 GB card, because the 16 GB card is priced wrong. Basically, if they wanted the 4060 Ti the 4060 Ti 8 GB costs $400. If they want that to be a $400 graphics card, it needs to have more than 8 GB. And since they went with the 128-bit bus, that means they have to go to 16. So they should have given 16 GB of VRAM on the 4060 Ti as the only option for this card. A card with this much performance is absolutely hamstrung with 8 GB. And if you're buying a card in 2023 that you might be using for 2, 3, 4, 5, 6 years, it depends on how long you hold on to your graphics cards, it's very evident that the newest games are at least likely to want you to have more performance. And it's a real shame to see something like this, where 60 FPS versus 85 FPS at 1080p very high settings, no ray tracing. A card can clearly handle the extra the extra stuff there. Now, not every new game is demanding more than 8 GB of VRAM, but basically, final summary, 8 GB, not obsolete. You can tweak settings, you can use DLSS, you can lower graphics settings, but think about the price you're paying for your graphics card. If you're buying a brand new graphics card at a high price, ask for enough VRAM for it to not hamstring itself in the latest games. And I think that, well, nobody can completely predict the future. It's obvious if you look at VRAM usage over time, it goes up. Right? It goes up over time, and in 2023, we're seeing a lot of examples of games needing more than 8 GB of VRAM, and this will get more common over time. And don't forget that if you want to get rid of your 8 GB card, you could sell it to Jawa. And I hope all of you have an excellent day.